So I know some of you have been bashing your head against this one. It starts off harmlessly enough. It seems like everything else. And then you simplify out, and then you get to a point and start scratching your head. Okay? So just for the sake of it, maybe you haven't seen this before, you had trouble at the beginning, or you're not sure if your beginning was right or not. Let's start this out. Okay? So, first step in induction, always test. Okay? Okay? So it's a pretty easy one, yeah? N squared plus 3, sorry, ones, not n's. 1 cubed, it's a cube too, that's nice. Times that, what's that? Okay, so 1 plus 3 by 2, it's equal to 6. And sure enough, that's divisible by 6, at least I hope so, okay? So it's true for, gentlemen, thank you. It's true for the first allowable value. Yes, true for gentlemen. Also true for, anyway, okay. So now I assume, by the way, I've noticed for myself, and this will become important later on, I've been a bit sneaky and been forgetting to declare an important part of this. In other questions we've been solving, it hasn't been that important. But in these divisibility ones, it's vital, okay? Every time you introduce a value or a pronumeral, right, a variable, you need to give it some conditions, right? We've been talking about some of them, but I've noticed I've been forgetting one. So, my bad. You might need to go back through some of your working and add it in. But when we assume this statement, that it's true for n equals k, I've been forgetting that we've got this k, right? And we haven't been saying anything about the k, okay? Now, in this case, the only condition that we need to meet is that k is an integer. Okay? Sometimes later on, it'll be k is an integer and it's this big. Okay? Sorry, it's a positive integer. For some of the later ones we're going to look at, particularly for inequalities, it only works for values larger than 6, 7, 8, that's the standard. Okay? So we need to introduce some conditions about it. Assume true for n equals k. So, i.e. k cubed plus 3k squared plus 2k is equal to 6p, where, and you can introduce both of these letters at the same time. So I would just say where k and p are positive integers. Okay. Now the proof. Prove for the next value along. Okay. Namely, k plus 1 all cubed. Again, be watchful for your brackets. And that's some other multiple of 6. Okay? Okay, now, where does our proof actually start to go? If we start with the left-hand side, it seems like if I want to bring this in, I'm just going to have to expand everything out. And sure enough, that's where we've got to go to begin with. You could factorize if you like take out the factor of k plus 1, but you're going to have to break it out eventually anyway because you need, see this has a k cubed in it, right? So you're going to need to get the k out of there, right? You're going to have to expand everything, which looks a bit ugly, but it's what you need to be able to actually substitute your assumption in, okay? Otherwise you end up with fractions, which is a bad idea because it's all about divisibility, which is about whole numbers, okay? So if you introduce fractions into it, you're sort of undermining your own proof, okay? So I'm going to expand. Okay, now, I want to think about how can I bring my assumption in, and I've got a k cubed in my assumption, right? So that looks good, I've got one there, and I have one, and only one, here. There are no other k cubeds, okay? Now what that indicates to me is that all this other stuff, right, is going to have to not be included in the assumption, okay? So you're going to have to be comfortable with that sort of awkwardness for a little while we simplify it out as far as we can. Okay, so I want not just a k cubed, but I want a 3k squared, and conveniently I have one right there. Okay, so this other k squared, right, 3k squared, I can't bring it into my assumption, right, because I don't have the numbers for it, right? And then I have a 2k there. So I have a 2k here. So there's my pieces that I'm going to substitute out. Okay. So I'll say that's equal to 6p plus, and then I've got all my other bits, so I might as well collect like terms. So what have I got here? 3k squared plus 9k plus 6 by assumption. Now this is the stage at which some of you will think, have I done something wrong? Okay, because usually the number that you're after, divisible by 6, right? Once you factorize it properly and substitute your assumption, you get like a whole bunch of 6s or a whole bunch of 21s or whatever number it is. And you look at this and you think, okay, so what are we going to do with it? Before we deal with that, let's get these 6 numbers out of the way. Okay, so I've got my 6p and my 6 out the front, and then I have these two. Now, I'm just writing them in brackets just to make it obvious that I'm saying this whole thing is divisible by 6. And I know that this part is already divisible by 6 because I have the right numbers. Okay? If the whole thing's divisible by 6 and this part is divisible by 6, it implies this also being divisible by 6, which doesn't seem, well, seems a bit counterintuitive. Okay? How does it work that this is divisible by 6? Now, what I would recommend you do, because you sort of, right now you have the advantage of me telling you this is right, okay? So you know, all right, even though it looks weird, I'm correct. If you get this question in an exam and you're like, how do I know whether this is actually right or wrong, right? Maybe I just messed up my arithmetic somewhere. Do I have to go searching for an answer, okay? Or are these numbers correct? What do you do? If you're saying this is divisible by 6, how would you know? Throw some values in. Okay? You put 1 in, for instance. 1. 3 times 1 plus 9 is 12. It's divisible by 6. Okay, try another one. Try 2. 3 times 4, that's 12, plus 18, that's 12 plus 18 is 30. Also divisible by 6. You can keep going. Just to satisfy yourself. That wasn't quite induction, but so you can see, all right, I haven't gone wrong. This is actually right. So I'm not looking for an error up here. I've just got to deal with this guy. Okay. So what are we going to do? Let's keep marching on, and we'll see if we can simplify this just a little bit. Okay. I got a common factor here, right? Namely, 3k. Okay. Now, when you look at this, okay, we're so close. But because you haven't seen this kind of question before, it's kind of like, well, what do I do? Let me put it over here in a different color. K plus 3 and K. Think about these two, right? K, and this is why I said it's very important that we talk about it, K is an integer, right? K is an integer. So when you think about these two numbers, this is a product, right? Any whole number you like, if you put 1, 2, 3, 4, 5, 6, 7, 8, 9 in, okay? You'll get an odd number and an even number, or you'll get an even number and an odd number. Can you see that? Okay, because they're always 3 apart. So both can't be odd and both can't be even. But one has to be one and one's the other. Okay, so therefore I can say that this is an even number. Okay, you see the step I made, right? So I'm actually going to bring that in to my working. I'm going to say it's equal to 6p plus 6. Actually, I might include down here. But K is an integer, right? Hence, I said this to a few of you before, right? One of these has to be even. One of them, at least, right? Hence, either K or K plus 3 must be even, right? See, induction's all about logic, okay? So therefore, I'm going to say it's plus 3 times 2r, where 2r is equal to that, and r is an integer. Okay? And now I have my 6. Okay? 6p plus 6 plus 6r, and I think you can probably take it from there. Okay? So it's a weird question because you have to think about it, okay? It doesn't just follow the nice 4 steps. You've got to use your brain for it.